So hey everyone, welcome back, and I hope you guys are doing well. So today we are going to solve another LeetCode weekly contest, and this one is the first question. So without wasting any time, let's get started. So this one is the maximum score of a split. I think this would be a easy problem because it's really crystal clear if you have work upon or solve a various problem related to prefix sum or suffix sum, right? So without wasting time, let's first understand what the problem is asking to us to solve. Like you are given an integer array nums of length n, choose an index I such that for like we have to split an array, and what the condition in which we have to split. Prefix sum of I is the sum of the element till ith index, and suffix minimum is the minimum value among I plus 1 to the rest of the element. Okay, the score of a split is at index I defined as score of I is prefix of I minus suffix of minimum of I. Return an integer denoting the maximum score over all the valid split indices, right? So what we have to do over here is, let's say if we are at a ith index, so till ith index, for example, like if we are starting from 0 and till ith index, we have to calculate their sum, like calculate their sum, right? And after I plus 1, from those elements we have to check, like we have to find the minimum one, right? For example, if this is the example, and if I'm do the indexing like 0 1 2 3 and 4, right? So these are the indexing of the elements. Let's say if I am at the second index, so till second index I have to find the summation of the elements, and after that, after I plus 1 and means 3 to 4, I have to find the minimum, and from them I just have to calculate what they have mentioned the formula prefix. It's if I write over here like prefix I, let's call it, minus suffix minimum of I, which we have to calculate, and we have to maximize this particular thing. So this question is quite clear what we have to do, like what's the brute force solution which we can produce over here. So brute force is quite clear, easy. If you are at a ith index, so from there we just have to run a loop which calculate the sum of the previous element, and from I plus, like what I have to do, like from 0 to example ith, we just have to run a loop to calculate the sum, and after I plus 1 I just have to run uh, another loop to actually find the sum of find the minimum element, right, which they have actually mentioned in the problem statement. So the brute force is quite clear. We just have to run two inner loop inside our loop, right? And after that, once we got these values, we just have to subtract them and uh, take them as our summation, and we just have to like maximize our sum over here, right? So this is the problem which they are asking us to solve. So brute force is quite clear, but if you see the time complexity become O of n square, because inside like upper loop we are running two different loops from I minus 1, like from 0 to I and I plus 1 to n, so which is equivalent to O of n square. So how we can actually improve or optimize this particular problem? So if you see, for example, let's assume you are at a second index. If somehow you got to know about the summation of till ith index, and same case you got to know about from I plus 1 to the end what is the minimum element. If you get these two information, then everything become easy, right? So what I'm trying to say is, till ith index sum, and after I plus 1 the minimum element. If you got these two information, then it become really easy for you to actually come up with a solution, right? So in order to achieve such scenarios, what we generally prefer, we have a concept of prefix sum and suffix arrays which actually solve our such situation, and we generally call them as a pre-computation logic, where we actually pre-compute the values and then just simply traverse over the array and simply calculate our result, right? So to better understand this, let's see the code what I have actually did over here. So if you see, as I mentioned, we need two different arrays prefix to like calculate the sum, because in this particular problem they are asking two different things for two different arrays, right? But some problem want you to do the same thing from till 0 to I and I plus 1 to then. So in that case we use both the array but in different manner, right? But here we have to calculate completely different things, right? So to calculate the sum, and for this, for keep track of minimum value, right? So this is what we are doing over here. And so what I am doing is I'm just calculating the sum. I'm just calculating and storing inside the sum and storing from the ith index, because we have to include our ith index, right? In case of suffix, we have to find the minimum, so I'm doing the same thing over here as well, but I'm starting from the back, right? And while calculating the answer, make sure to read this particular statement. They have mentioned I should be less than n minus 1, which means we are not going to consider the last index, right? So in order to such handle that particular scenario, I have been using, and I'm just running my loop to n minus 1, because we don't have to consider that particular part, the n minus 1th element, because we cannot able to split from the last index, right? We need some index so that we can split an array into two different parts. But if, let's say, like if we have a array like this, so we cannot split it from here. Coming at, like, if we split from the last fourth, so we do not have any other element rest, right? But they have clearly mentioned the value of I should be less than n minus 1, so that what I have been doing over here, right? And for the prefix, I'm just calculating the maximum value by subtracting the prefix, which actually store the summation, and suffix of I plus 1. Why? Because if you see, they clearly mention over here is, to in order to calculate the result, you have to prefix of I and suffix of I, right? But the split is valid where we are making a split of 0 to I, and for the minimum we are calculating from I plus 1. So we cannot consider the ith value, because ith value include the current value where from where we are calculating the summation, right? So in order to avoid, we are calculating from the last I plus 1th element, that will actually gives us a right answer. And I'm just storing inside our score variable and updating it as per we got a maximum value. So this is the simple code, and I think it's probably an easy question. It might be something not that much difficult, but for the people who are just starting, who are just learning about these concepts, they might feel little difficult, but not too much. I think I should say definitely they are able to come up with a brute force solution. So yeah, but still learn this concept. The prefix sum and the suffix sum problem are really like the concept are really good. You are actually going to use them in advanced problem in upcoming days when you encounter some problem, maybe like most of the time when you are dealing with some online assessments. So this is it about this. Talking about the time complexity, so you see it's clearly of n, because we are running over here is O of n loop. Same, it is also O of n, and here we are just calculating, so it's O of n, which is like, if we simply write over here is O of n plus O of n, and if you see it's 3 O of n, where we remove the constant, so it is O of n, right? And talking about the space complexity, so it is also like it is 2n 2 of n, because we are storing two different, like creating two different prefix and suffix array, right? So it is also going to be O of n. So this is the solution for this particular problem, and this is the time and space complexity. It is, I think it should be clear to you. It's really easy problem, and if you feel little bit of difficulty, so don't worry, you are just starting. You will definitely got to learn something from this video. And if you if you understand this video, if you understand the concept, do let me know in the comment section. Do like the video, so that I got to know about the way of explanation of mine, and I also improve, and I also get a little bit of motivation to make some more video in future as well, right? So this is it for the video, and I hope you like the video. Bye bye, take care.